So when we graph these three graphs, put them in a graphing tool and then plot those graphs. And when you plot these graphs, we're going to end up with three graphs that kind of look like this. So I've got a graph. My first graph here looks like it's got, it just bounces off the x-axis like this. Okay, something like that. And notice that the parabola is facing up. It's got a y-intercept of 1. If we actually graph the other one here, okay, this one here, it's going to go open up. It's going to have a y-intercept of 1. In this case, so the vertex is now somewhere over here. And then for that last one, it's going to have the same opening, same shape as those. Both of those, these both have the same shape. The third one has the same shape as well. Okay, but in this case, the y-intercept, and the y-intercept still is 1. Okay, these all have a y-intercept in the same place of 1. Okay, but now the vertex of this one is going to be somewhere down here. And these are supposed to be the same shape, but the vertices all end up in different places. Y-intercepts are all the same. Okay, they all have a y-intercept of +1. There's 1 here, +1 here. And this one also is +1. Okay. But the vertices all are in different places. So it's not really that evident what it does. It's really hard to kind of tell, but it does affect the vertex somehow. Now, what I would like you to do is I would like you to plot x squared plus bx plus 1 and then add a slider for b. And play around with that slider and see what happens. Okay, see at what happens to the parabola. So the shape of the parabola doesn't change, right? Because the shape is determined and the orientation is determined by the a value of 1. The y-intercept won't end up changing, but the vertex is going to change. It's going to move in a way, and you might recognize the pattern that it follows. Okay, so just give it a try and see what happens with that.